What is virtualization? How and why is it used? What are the most common virtualization technologies, including hypervisors and containers? And how can you use virtual technologies practically and understand their applications to security and modern computing? These are some of the questions that we're going to be answering in today's video. This video is of the virtualization and containers room that is of the network and system security module in the security engineer pathway of TryHackMe. My name is Hank Hackerson at Hank Hacks Hackers, and if you want to get more video about the security engineer pathway or cybersecurity analysis, ethical hacking, pen test plus, any of that stuff, I do invite you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. And definitely click around on the channel because we have a lot of playlists right now that had a lot of great content that you can use to become a cybersecurity professional. Now, without further ado, let's jump into the virtualization and containers room. All right, so what is virtualization? At the most basic level, it's the concept of encapsulating the abilities and features of a physical machine in a virtual environment. It's also known as a virtual machine. So when you virtualize something, that means you're basically creating a virtual Windows machine or a Linux machine, and then you can access that on any other type of machine. And one of the greatest images that I saw was this like really cool image. I'll show it to you right now that basically gives you a really perfect one-shot idea of what virtualization actually is. And this is basically it. So you have a car inside of another car. And this is, as far as I'm concerned, the best image that can describe what a virtual machine is. You have a machine inside of another machine. And virtualization essentially means creating, setting up a virtual machine inside of a physical machine. So why would you do something like this? Why would anybody do anything like this? Mostly, and the biggest reason is that it's really less expensive than anything else. So imagine having to pay, I don't know, a few $1,000s, depending on what kind of server that you need or what kind of computer that you need to build a physical server and then create, run it. And then there's the cost of the running of it, the electricity, all of that stuff. And then imagine that you need to upgrade it. And so if you needed to upgrade it, you would need to buy new pieces and new parts and upgrade it that way. And it just becomes even more expensive versus going to Microsoft Azure or Amazon AWS or Google Cloud, any of these cloud service providers, and getting a virtual machine through them. Another really good one is Linode, and getting a virtual machine through Linode. And then that way you essentially can get any kind, any level of virtual machine, any operating system. If you don't need it anymore, you just cancel that machine, and you only pay for the week or for the month that you used it. Or if you need to upgrade it, you would upgrade it at a couple of clicks, and it would be literally a fraction of the cost that it would take to build a physical machine and update the physical machine. And then there's the scale of it. So if you need to scale up your physical servers, that means you need to go buy more physical servers and create more computers and get more storage to be able to house these things, and the security of it, and then the insurance and all of that stuff that goes into it, versus you just scale up by adding a couple of more machines to your virtual servers and adding some more virtual machines. So it just makes it super easy to scale up the resources that you need to do something like that. And then of course there's efficiency that has to do with it, which means it decreases the resources that are allocated. So if you have to spend, if you only have a limited amount of money to spend, then you go ahead and use a small portion of that, and you get a bunch of virtual machines instead of spending that entire budget on building one machine. And then same thing again to the electricity that you would need to pay for, and you would need storage to be able to house all of these machines, and rent that goes to that, and the lease. And then you need to get fire and hazard type of insurance to make sure that if anything hits the fan, then you actually are covered for the cost of those things. So there's just so much cost and inefficiency that comes with a physical environment instead of getting a virtual environment. So there's a lot of benefits to it, honestly. And these are just a few of the key important ones. So virtualization technology is what one of the big things that a lot of people have kind of in mind. And especially this was one of my questions to him, like, well, how the hell does this even work? Like, if I wanted to do this, where do I need to go? What do I need to do? And what are the different pieces, the steps to getting this done? So it's an in-depth question. They call it an intricate question. I think it's a sophisticated, in-depth question, and we're going to break down a few of the different technologies and platforms that are used to making something like this work. Something like the what was it called, hypervisor and containers and stuff like that. These are all things that actually happen or happen to be the technology that's used to make these things. And there's something called VMware, and there's a lot of different techs that it allows you to do this. And we need to expand on the definition of this to be able to understand what that actually means, what the different technologies are. So virtualization creates an abstraction layer, and this is a technical term, right? So it creates an abstraction layer over computer hardware. An abstraction layer allows a single device to be divided into multiple virtual computers, also known as VMs or virtual machines. So one computer, your computer that you're on right now, if you're watching this from your computer that you're on right now can house a bunch of different virtual machines. And that's what that specifically means. And you could do it by actually downloading the ISO, the image of the virtual machine that you want, and then putting it on a USB drive or installing it on a separate drive on your actual computer that you have right now. Or you go and you buy a VM for a couple of weeks or a couple of months from Linode or Google Cloud or something like that, and then you pay for that monthly. And then from there, you get a lot of different perks and benefits. For example, not having to download the actual image, disk image, and we'll get into that in a little bit, the disk image of the machine onto your computer, and then taking up space on your computer, and then launching it from your computer, which will take up memory and RAM and processing power from your computer. So all of those things happen when you download the disk image onto your computer and virtualize from your computer, versus when you go into a service like Linode, and that's the one that just keeps coming to mind because it's easy to pronounce, and launching it from the Linode portal and from that platform. In simpler terms, it means that the virtual machine will have access to logical resources that are abstracted from the physical resources. That's basically what that means. And that's supposed to be the simpler term. So if you don't know what logical resources versus physical resources are, that might be a little bit over your head, but I think you can probably figure it out. So then there's the virtualization structure, and it's implemented using an engine machine format, which means a software or system creates an abstraction layer that we talked about, and it allocates resources, while an operating system or application can then be installed on top of that virtualized environment. And the operating system installed on a VM is also known as the guest operating system, guest OS, as opposed to the host OS, which is where the virtualization engine is running. So we're going to talk about this in a little bit, and we're going to talk about virtualization engine called Hypervisors. So the first couple of questions here is scalability a primary benefit of virtualization? And we already discussed that, and that is a yes. And what is the operating system of a virtual machine often referred to as? And so that would be the operating system of the guest OS. There we go. So we got that, and now we can move on to our next piece, which is hypervisors. So in the virtualization, what is virtualization? We looked at a high-level view of this, and now we're going to actually go into the first type of virtualization engine, which is the hypervisor. And it provides the ability to create the abstraction layer that we talked about before between the hardware and the software. So between your computer and whatever it is that you want to download as your virtual machine. So it also generally includes some form of management application and software to provide an interface between the end user and the abstraction layer to create or load the actual machine. So there needs to be a specific not a third party, but an in-between kind of a software that allows you to launch the machine. That's kind of the big deal here, is that once you download the disk image on your computer and you want to launch it, you need to use some kind of software to be able to launch it. Hypervisors are separated into two categories, and they're determined by their position relative to the hardware. So they can either directly create a lightweight operating system on top of the hardware, or add a hypervisor as an application on top of a pre-existing operating system. So type 1 is also known as the bare metal hypervisor, creates an abstraction layer directly between the hardware and the virtual machine without a common operating system between them. So instead, the hypervisor is the operating system, and it's often headless with a web-based management portal that's remotely accessed. So we talked about this. Linode would be an example of this. These hypervisors are designed for scale and deploy a large number of virtual machines at once, and they're extremely lightweight to dedicate the most resources to the virtual machines. And this is kind of what it looks like. So you have the hardware, which is your machine, and then you have the hypervisor that ends up acting as the portal. And then on top of that, inside of the hypervisor, you have the guest OS. So this is one machine, this is another operating system, so on and so forth. So examples include VMware, ESXi, Proxmox, VMware vSphere, Xen, KVM, but there's a lot of them. So type 1 hypervisors, if you Google it, or a headless hypervisor, if you Google it, you'll get a lot of different examples of that, and companies that offer them. And a lot of these things are open source, by the way. So you can get open source free versions of this. Obviously, they're not as robust and they don't offer as many features, but they're functional and you can run machines from them. So type 2 hypervisors, they're known as hosted hypervisors. They create an abstraction layer from a software application built on top of a pre-existing operating system. And unlike type 1, type 2 are often managed directly from the application through a GUI, and these are often designed for end users or individuals such as developers, and are not strictly designed to run a large number of virtual machines for scale. So you have the hardware, and then you have the host operating system, meaning the operating system of the hardware, and then you have applications that are inside of the host operating system, and then you have the hypervisor that is also part of the applications, or I guess on the same level of the applications. And then from there, inside the hypervisor, you can launch your guest operating system. So the host operating system would be if you have a Windows machine. So I have a Mac right now. So my Mac OS would end up being my host operating system, and then I have a bunch of applications on my Mac. And then in addition to my applications, I can have a hypervisor that can allow a guest OS, a Windows machine or a Linux machine to be run from my Mac. And that would be considered a type 2 hypervisor. And it's going to be available only to my specific Mac because I'm using it as the developer, and it's not meant to be accessed by a million other people inside of the organization, right? So that's kind of the big difference here. So what type of hypervisor is VirtualBox considered? And that is a type 1. And what are type 1 hypervisors also known as? And they are known as bare metal hypervisors. All right, now on to containers. Hypervisors work as expected for a large number of use cases, but begin to encounter issues when scaling lightweight applications. So they're called microservices. And they give us a good example of an application architecture that encounters issues when deployed from a hypervisor, right? A microservice is an application structure that's broken up into smaller services. As the name implies, it's a microservice. And those smaller services are scalable and use lightweight protocols and features. And the lightweight nature of this poses obvious issues that require a large number of virtual machines, each with high resource usage. So containers are the current solution to the issues that are encountered with hypervisors at scale. So if you can imagine what a container, a microservice would be inside its own container, right? Containers have a lot in common with virtual machines, but instead of being completely abstracted from the host operating system, containers share some properties with the host operating system. They have their own file system, a portion of computing resources like the CPU and the RAM, a process space, and a few more other things. Apart from obvious benefits, containers are also portable and robust. So they're portable and robust, which usually don't go hand in hand. So that's what makes them actually pretty freaking useful, because they're not completely abstracted, right? So container engines are second types of virtualization. So we had virtualization or the hypervisor as first the type of virtualization, And then you have the container as the second type of virtualization. Since virtual machines use a hypervisor to create an abstraction layer for virtualization, containers use a container engine to create an abstraction layer using resources logically instead of physical resources. So what we're going to talk about in the next one is the Docker, which is a really big concept you're going to run across if you have to do anything like this, any kind of sysadmin type of an job or job description. You're going to hear the word Docker a lot. Help desk and IT support, all of those people also use Dockers, and they have to learn how to navigate Dockers and basically know how to manipulate them, install within them, uninstall, troubleshoot, patch, things like that. So containers are containers completely abstracted from the host operating system. They are not. They actually use certain pieces of the host operating system like the CPU and the RAM and things like that. So let's actually talk about the Docker now. All right, so this task requires for us to load a virtual machine, and that one is up and running in a little bit. So while that's running and loading, let's read into this. So it says, if you're familiar with containers, Docker is likely the first name that comes to mind. It's a container platform and engine that is used to run Docker images, and we talked about disk images earlier, and it runs those images as individual containers. And our machine seems to be loaded. Well, it has a connection error now, so we're just going to wait for that to fully load. So each Docker image is built of a base image, such as Alpine, Ubuntu, anything like that, and it's specifically built for use in containers and is very lightweight. So to build one, a Docker file must be created, and it defines the base image for a container. And image in this case, we're going to be using this a lot. An image is essentially a compact version of the actual operating system inside of that container. Is called an image. We're not talking about like a visual picture kind of a thing. You're talking about a disk image, operating system image, a machine image. That's what we're going to be talking about, and that's what it means in this context. So for more information, you can go to the Intro to Docker room, which I have not done actually. So that will be something that we can check out later, and we're probably going to run into it at some point. So running and interacting with a Docker container is done typically through the command line, unless you actually use a GUI, and those things actually are super helpful as well. But I always like learning about the command line first so that you know what's going on in the background and your foundation is super strong. And then when you use a GUI, then it becomes even more useful for you, and you have even more appreciation for it because you know what's actually happening behind the scenes in the actual command line itself. So Docker Hub is a remote repository for Docker images, similar to GitHub, which is a remote repository for Gits. Using Docker Hub, we can pull images and push our own images, or push our own images. So Docker pull pulls the image, and so it would be the user as well as the image that that user belongs to. Alternatively, a container image can be automatically pulled when running the container for the first time. Once a container is pulled for the first time, it'll be cached locally, and Docker will look for it locally before attempting to download it. So if it doesn't exist, obviously it's not going to work. So then you have run the user image. Once it's started, we can verify that Docker engine is running by running the container by listing processes running in Docker using this below command, which is the PS for process command. From the process command right here, you may notice that the container will be assigned a random identifier, IP address, and network interface. So now we can actually do this with our virtual machine that is now populated, and we have the user and password for it. So before starting it, we have to first introduce two new flags that must be used with it, which is the D flag as well as the P flag. And the D flag is detaching the container from the current terminal and exposes the external and expose ports externally, which is the P flag right here. So the required syntax will look like this. So Docker run P on port 5000, right? The D which is this is the username, and then this is the image that we're going to be running. And then to verify that it's running, we can scan the container or access the designated word in a web browser. Certain special characters may not be visible in the provider VM. Doing a copy paste, when doing a copy paste, it will still copy all the characters. So that is all good. So now what we can do is first we're going to virtualize this machine, and then from here we're going to go and access it by going to our web browser at that port, and then we're going to find the flag that we need. So here's our Linux machine. If you haven't seen this before, this is exactly what a Linux server or a Linux machine looks like. It does not have a graphic user interface. It's all command line. So that's why it's very important for us to be able to do this. So what we're going to do in this particular case is we're going to run the command that we have here and see what we can find when we actually go into the web browser. All right, so I just went ahead and typed in clear to clear the screen of the text that we had previously. So the first thing that we want to do is we just want to check to make sure that we actually have this image of this sample that we're looking at down here. We just want to make sure that this is actually running in our repository. So we're going to do docker images as our command, and there it is. So we actually have the repository Krylik, I don't know how to pronounce that, Krylik THM example app. And so they did mention that some characters aren't going to be visible. For example, the underscore. The tag would be the latest. The image ID is here, created 13 months ago, and it's a 59 megabyte file. So from here, we're going to go ahead and just run the command that we have over here to just make sure that we're going to be able to run this particular repository that's here. So we're going to do, we're just going to type this out. Okay, and that's running, and I think it's running because it finished and it gave me my little $sign, which means that the command line is now all good. So which means that I should be able to just go to this link now because there's no web browser or anything. So let's see if this actually runs. No, it's going to machine IP 5000, so I don't think that's actually going to work. So let me see, how am I supposed to access this? Because this doesn't have a web browser inside of this machine. Which means that I have to probably go into my attack box or something like that and then access it that way. So I'm just going to start the attack box, and that's going to take a few minutes as well. And once the attack box is up, I'm going to be able to go ahead and do it. And if you want to use your own Kali Linux machine, or if you want to just SSH secure shell into this machine, you can. For the intensive purposes of this video, I'm just going to use the attack box that's provided by TryHackMe to go ahead and just run this, and from there we're going to be able to get access to our little server that we just launched. All right, cool. So this is what the attack box looks like. It's basically an Ubuntu Linux machine that allows us to do all kinds of fun things. In this particular case, the only thing that we're really trying to do is just go to this web address right here. So I am going to type that inside this browser, and we're going to see what our flag is. So let's check it out. Okay, there you go. Very basic web page. Nothing fancy about it, just one giant headline that is our flag. And that's it, just like that. We copy that and we paste that, and boom, it's running. That's it. So just to kind of review what happened, right? So I didn't need to pull any kind of an image. I didn't need to run any kind of an image because it was all just running. So all I did was I just went into our Ubuntu machine and I just ran it. I just ran the command that they gave us right here. And I could have done the same exact thing by doing an SSH and logging into this machine and running it that way. So what that looks like, so if you did this from your own machine and you wanted to SSH into it before you did the run command, you would be able to do it by literally just opening up a terminal and just SSHing into this. So here's what that's going to look like. So I'm just going to minimize this real quick, and then we're going to open up a terminal, and then we're literally going to SSH using these credentials right here. We're just going to SSH into this machine. So There's the SSH command. You press enter. Do you want to do this? Yes, I do want to do this. And then now I have to type in the password, and it doesn't show you what you're typing, so you just got to make sure that you actually type it in correctly. And there you go. Now I'm into the actual machine itself. And so if I just did the same exact command, right? So if I just do docker images, it'll give me what the image that was available on that Linux machine. It'll just show it to me on this thing like that. So same exact image. And so then what I could do is I could just go ahead and copy paste this and just run it, and then go into my browser and then visit that address, so on and so forth. So the rest of the commands would be exactly the same. This is just what it would look like instead of actually loading it from the Linux machine that it gave us, from this machine. Instead of loading it from this, you would load it from your SSH portal or your web shell, so to speak. So that's pretty much it. That's all we had to do for our Docker task here. And so now I'm going to terminate this because I need to start another machine for our Kubernetes task right here. So let's go and look at Kubernetes. All right, so Kubernetes, through the use of hypervisors and containers, most problems associated with traditional computing are resolved, such as cost and efficiency. But it still leaves the question, what if we need a faster and more scalable solution? And that is load and other criteria changes, the resources or the number of instances allocated to the application increase or decrease on the fly as needed. That part, that on the fly part, which means like with a couple of clicks, you need to be able to click around, virtualize something, take something down very quickly on the fly, right? So Kubernetes, also shortened to K8s, is one such solution as an orchestration platform. An orchestration platform aims to integrate into other products such as Docker and extend their capabilities or synchronize them with other products or applications. It relies on these traditional virtualization models like hypervisors, containers, and extends their uses, features, and capabilities, which is literally basically what this freaking thing said right here. I don't know why they rewrote that sentence. These capabilities include horizontal scaling, traditional vertical scaling. Horizontal scaling refers to adding devices or machines to handle increased workloads rather than adding logic or resources such as CPU or RAM. So I'm going to show you what this looks like. Hold on. So this is a pretty good demonstration of vertical versus horizontal scaling. So vertical scaling means instead of having this small server, you just get a much bigger server, right? So you add processing power to your current one server. So you just make it more powerful. You vertically scale up. Horizontal scaling means instead of making this thing bigger, you just add another server or add another server or add 10 more servers, whatever that may mean. And sometimes what you need to do is you just need to duplicate the same current server that you had by 100. And instead of virtualizing every single one, a lot of different portals and platforms allow you to say, hey, you know what, this thing that I have, I want to duplicate this by 100 and create 100 new copies of this one particular server horizontally, which means what? In this particular case, in this vertical environment, that same user, so let's say you have one system admin or one user that is using this machine, and now they have a much more powerful machine that they can use. In this particular case, instead of just having that one user, now you have 3 users, or if you had 100 of these, you have 100 users, right? So that's what that looks like, that they can go and access their own account on their own machine with their own files, so on and so forth. So that's the difference between vertical scaling and horizontal scaling. And it's just a lot of times it's easier to see it in a visual instead of just reading through some text and stuff like that. So that's what horizontal scaling is. Then you have extensibility, which means that clusters or a bunch of machines, it's also known as a cluster. So let's say you have 10 machines, that's a cluster of 10. They can be modified dynamically without affecting containers outside of that particular group or outside of that particular cluster. Then there's self-healing. Kubernetes can automatically restart, replace, reschedule, and kill containers that are not properly functioning based on user-defined health checks. Very, very cool. automated rollouts and rollbacks, so it can progressively roll out changes to the containers. As changes are made, it will monitor the application's health and decide whether to continue the rollout or roll back. This ensures the constant uptime of your cluster even if some containers fail, which is very, very useful. So another version of this is that you have 10 machines and you need to roll out another 10. You can do that without affecting the first 10. You have 10 machines, 3 of them fail. You can just add another 3 and get rid of the 3 that failed without affecting everybody else. So automated rollouts and rollbacks, the automated part means that you literally check a box that says, I want to automatically roll out or roll back something based on its function. And so if it's not working, automatically it just goes to another machine that will actually work just in case that first one for whatever reason crashed. So whoever the end user is, there is no disruption of service for them. And that's very, very important. It's done automatically. Your cloud service provider will do it for you. Kubernetes in this particular case being the specific platform that you're using, Kubernetes will end up doing it for you. The orchestration of Kubernetes, that's literally what that means, is that you just assign certain tasks and you choose certain options, and from there Kubernetes does all of the management and administration for you. It's super freaking useful, honestly, when you think about it. Instead of you having to constantly be there stressing out and trying to figure it out, and it does it for you just by you predetermining what you want. It's super useful. So to get hands-on with Kubernetes, we've given access to a pre-deployed cluster. So we're going to actually make sure that we launch this, and while that's happening, we can read the rest of this. So to get hands-on with this, we got access to pre-deployed cluster configured with kubectl. And because Kubernetes provides most of the basic automation by default, we want to explore the differences between Kubernetes and a traditional virtualization platform on our own. So that being said, Kubernetes is a large platform with a pervasive list of features. What a word, pervasive. We encourage you to continue investigating DevOps and the features of Kubernetes, and we will only provide you with a basic set of questions to get started. So to access the cluster, deploy the machine. We can also SSH into the machine, so on and so forth. So I'm just going to wait for the IP address of this thing to actually load. And then once it loads, I'm going to give it a few minutes. It's telling us give it 3 to 5 minutes for it to fully load. So once it actually does load, and oh, it looks like it's loaded. So let's see if it actually works. Once it does, then we're going to go ahead and start this whole thing. So let's do it. All right, so while we are waiting for this thing to fully load, there is a little reference link that they've given us, which takes us to the Kubernetes quick reference guide here. And so we can run a bunch of different types of commands to get access to a bunch of different types of things using the Kubernetes command line. And from the very, very top, it seems like it would be a good idea for us to turn on autocomplete so that we can, autocomplete things without having to manually type everything out. So I'm probably going to do that first. And then from there, we'll just go ahead and answer the rest of these questions. And it actually tells us right here that before proceeding, ensure that all clusters are started by running minikube start. So let me run minikube. Or you know what? Let me go to the attack box and do this just to make it a little bit easier, because that allows us to copy paste things a little bit more easily and kind of go back and forth between this thing. So we're going to first clear that, and we're going to SSH into our new machine by using the new IP address that we got. And yes. All right, cool. We are now in the machine. So let's do minikube start. Okay, so it's basically saying that it's not running yet. So I'm going to give it a few more minutes before I try to restart that thing. Okay, cool. So that time it actually worked. And so this is what it actually looks like when you do minikube start, and it goes through all the prompts and it says done. kubectl is now configured as a minikube, or to use Minikube versus the other one where it didn't work and then it says signal killed, so on and so forth. So we now actually have our Minikube started, so we can click on complete on this thing. And the first question here, it says how many pods are running on the provided cluster. So let's see what the hint says. It says kubectl get pods. So that would be the command that we're supposed to run. So we're going to do kubectl get pods. And let's see how many pods we got. Okay, so one pod. Hello, TryHackMe gibberish, yada, yada, yada. So that's what it is. Okay, so hello, TryHackMe is one of one. How many system pods are running on the provided cluster? We're going to look at this, and it says get pods, it says get pods dash A. So same thing, we're just going to do a dash A at the end. So I think dash A may stand for all. So kubectl get pods and then dash A, and it's a capital A in this case. So let's see how many of those show up. Okay, so maybe instead of it all being one word, which this is kind of what it looks like over here at first glance, but now I realize that maybe there's a little space in between those two. So instead of it being as one thing, I'm going to do kubectl get pods space dash A, like that. And that should probably work. There we go. All right, so we got it. And so it says how many system pods are there. So we actually have several that are running. This first one is the default, and it doesn't seem to be a system pod. So if we're counting only the system ones, I think that is 7. So let's see if 7 is the right number here. And it is. Okay, great. So what is the pod name on the provided cluster? So hint is what? Get pods. So same thing. So it's going to be this thing right here. This full thing, I believe, is the pod name. So I'm going to copy that. Cool beans. And what is the deployment name on the provided cluster? So let's see what that is. So it says get deployments. I mean, these seem to be pretty freaking intuitive, really. Get deployments. Let's see what that says. It says hello, TryHackMe. So we'll just type this out. All right, cool. So what port is exposed by the service in question 5? What is this? I'm guessing this one is the question 5. So now what is the hint for this? So it says get services. Okay, so let's do kubectl get services. All right, so we got it. And so let's see, what is the port here? Node port? Is that the name? So hello TryHackMe is the name. And so I think I need to kind of expand this a little bit just so I can see what's going on. Oh no, here we go. So we got the ports right here. So once we expanded that, it made it a little bit easier to read this. So it's either port 8080 or 31449. So let's see, let's try 8080. Yeah, it is 8080. Okay, great. So there is that. And how many replica sets are deployed on the provided cluster? So it's going to say get rs. So kubectl get rs. And there we go. How many replica sets? We have 1 replica set. Very good. And what is the replica set name? And it's very similar to the other one, but now this time it has different numbers and characters at the end of it. So boom. And last but not least, what command would be used to delete the deployment from question 5? So it would probably be kubectl delete. I'm just going to try that. And then paste. Oh no, that's not the answer. Dang it. Okay, so what's the answer? It says kubectl help menu or online resources. All right, fine. So now we're going to actually go and use our online resources for this one. and I'm gonna search for delete to see what I can do here. So kubectl config unset. So maybe unset is the word that we want to use. Let's see what else we can find that has delete in it. So these are all the different delete patterns. So kubectl delete pods, delete so on and so forth. So delete a pod using the type and name specified, delete a pod with no grace period, delete pods and services with names as Baz and Foo, delete pods and services with label name, my label. Let's see, all pods and so on and so forth. So what is this? This is, what are we doing? It's a replica set name. So maybe we're looking for delete replica. Maybe that's what we need to do. Let me see. Let's go see what else we can find here. Yeah, I think it's one of these things. So specifically, I'm not sure which one it is. I think it's going to be pods and services, but I am not sure in this particular case. So let's see what we need to do. It's what command would delete the deployment from question 5. All right, so did a little bit of Googling because I actually couldn't find it inside this quick reference guide because none of the delete commands actually helped us. And then I searched for deployment because that's actually what we have here is a deployment. And it said, what is the deployment name? And that's what it is hello TryHackMe. So from question 5, this was the one. So hello TryHackMe, and it's a deployment that we're trying to delete in this case. So we need to find a command that deletes deployments. And so that's basically what I Googled. And the command is right here. So it says kubectl delete deployment and then the deployment name. So that's what we're going to try now. So I'm going to do this kubectl delete deployment, and then it's going to be hello TryHackMe. Hey, look at that. Oh, they've updated a lot of things about the design since the last time I accidentally clicked out of it, and now I can't share that I finished my thing for this room. I'm so upset. I wanna be able to share that on LinkedIn. Anyways, that is it. That was literally it for our virtualization and containers tasks and room. So hopefully you actually got a lot of value out of this and you learned some good things about virtualization, containers, of course, the hypervisors, Docker, and Kubernetes. As always, I encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out. We have a lot of good stuff that's coming out on this channel. It's all about security engineering, security analysis, penetration testing, ethical hacking, all that good stuff. And if you're studying for any of those certifications, or if you want to do any of those things for your day-to-day as a job, then this channel will be super helpful to you, I promise you. And there's already a lot of people that are coming through the comments and asking their questions, and we talk back and forth about a lot of these things. And if certain requests come in, I do go ahead and fulfill those requests for content and things like that. So I will do my very best to create content to actually answer your questions. Apart from that, I would love to see you in our comment section and just as a part of our community. And I will do my very, 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 very best to make sure that you are catered to and you're taken care of and you get some good content so you can learn some good stuff and become an ethical hacker, all that shit. So anyways, it's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. Love, peace, and chicken grease. If no one else loves you, Hank loves you. I will see you in the next room. Later.